Yeah, very good morning all. So today we're going to start with databases. So databases, there are a few services that AWS offers, or not few, many services that AWS offers for databases. Again, databases are very important constituent of building applications, building enterprise systems, right? I mean, you need some sort of a data store to store and process the data, correct? So that's where there are traditional relational databases, that you also learned in the beginning of this course on Oracle. And AWS offers a lot of those such traditional relational databases, plus, the other types of data stores, such as NoSQL data stores, right? Columnar data stores, right? And so on and so forth. So these are some of the flavors of databases that AWS offers as fully managed services. Let me just share the screen. So again, all of us know, what managed services are, right? Managed service is something that the cloud provider manages or the service provider manages. And all that we need to do is to just make use of it and start consuming it, right? So that's what managed services mean. So what AWS offers is AWS offers a full range of database engines as a managed services. They're called purpose-built databases, right? So because in older times, when applications were built, the application developers, the architects didn't have a choice than to use the available database engines, right? In those days, the only available database engines were relational database engines, such as Oracle, SQL Server, MySQL, Sybase, correct? And on the mainframes, mainframes used DB2, IBM DB2. So these are some of the database engines that were available, and these are called relational database engines, right? The reason why they are called relational is, they are they use tight coupling between say the schema, right? So when I say schema, the underlying data model, and they have some sort of a relation between one table and the other table, and they've got foreign keys, right? And they've got a fixed number of columns in the table structure, correct? And you won't be able to go beyond that. And if you need to make changes, then those changes will impact all the other rows, right? And you would need some sort of a definition language that would define how the tables and the structure of the tables would look like. And also they had constraints with respect to scaling, right? So they cannot scale beyond a certain point, correct? In terms of the data storage and in terms of the number of transactions that it can run, number of queries that it can run within a given period, right? And again, they had availability issues, right? So you cannot make them highly available, without sacrificing on certain characteristics, right? And again, clusters were there, but again, clusters are had its own complexities with respect to price and so on and so forth, correct? Maintainability, price, and operational overhead, and so on and so forth, right? So that's basically the relational database. I'm not saying that relational database is all bad, right? Because a lot of applications still use relational database, and relational databases are the right fit for certain types of applications, certain types of data store, right? But the problem was since only that was the only type of data store that was available, pretty much every other use case had to use only the relational database. But now it is not the situation anymore, because you've got something called purpose-built databases where you have different types of engines for different use cases, right? Like it's not like one size fits all. If you want to store and handle massive, scale of data, right? And you can actually use NoSQL, right? NoSQL can scale to a great extent. And then you have, if you want to store documents, then you can actually go for a document database. So it's where you can actually store documents and retrieve those documents. And if you want to build some sort of a blockchain application, then you can actually go for some sort of a Hyperledger based databases, right? So that's where it's called the purpose-built databases. It is specific to a purpose, right? I mean, it's not something which is a general purpose or default database, which is the only database which is available to make use of, right? So, I mean, gone over those days, right? So where you had to use only RDBMS, come what may. Okay, whatever be the use case, whatever be the situation, you had to always use an RDBMS. You had to either go for an Oracle or a MySQL or a SQL Server, Microsoft SQL Server. Correct? Now that's not the case. So now here in AWS, you've got a full plethora of database engines available, which are purpose-built, where you can build use case driven, highly scalable, distributed applications. Again, use case driven, right? And if I want to say build a, some sort of social media application, right? And that social media application would need to have, relationships defined and discovered hierarchically, right? Such cases, you don't have to use traditional RDBMS, right? You can use a different database. Again, as I said, documents. If you want to store documents, you go for documents, right? DocumentDB. AWS offers 15 plus purpose-built engines to support diverse data models, including relational, key value. Right? Key value is again NoSQL. Right? That's called NoSQL. I don't know how many of you have come across this term of NoSQL. NoSQL is basically an engine where it's not that there is no SQL. I mean, SQLs are still there, but it's not only SQL, right? You can store key value pairs, and you can have different heterogeneous columns, right? In the same table, you can have one row can have 2 columns, the other row can have 5 columns, right? So, but that's not possible in RDBMS. In RDBMS, the number of columns and the data types of each row is fixed. You won't be able to move away from that, right? You won't be able to change that. Document database, in-memory database, right? Like again, in-memory database provides fast. I mean, nothing is stored in the disk. Everything is stored in memory, right? And the whole database, the data is all present in memory. It just reads from memory. That's what gives the database a blazing fast performance. Graph database, where like social media that I said, right? I mean, you can use graph. Time series database. So you want to store, data coming from say sensors, and these sensors are, I mean, you are deploying it for a factory, where the machinery is continuously generating data through these sensors. So you want to store them in some sort of a database and then use it for anomaly detection and things like that. Then you go for time series database, right? Wide column, in columnar database, and ledger databases, where you want to build blockchain applications, you go for ledger databases. And they're all fully managed databases, which means that the underlying infrastructure, backup, provisioning, everything is managed by AWS, right? You don't have to do anything of that sort. All that you need to do is to build the business logic and start making use of the database engine. And performance at scale, right? I mean, usually you want to start small and grow, right? I mean, that's pretty much possible in AWS, where you just start small and grow as your business scales, right? And also the relational databases are 3 to 5 times faster than popular alternatives, right? I mean, you want to run the same database in your on-premise on a virtual machine in your data center, right? AWS gives you a 3 to 5 times faster performance for a better price point. And it also provides you high availability and security. So Again, you can make use of the multi-AZ features of the database, and keep using that and to maintain your applications in a better availability and reliability. Okay, so these are some of the database services that we have in AWS. Relational, again, all of us know, we would have learned relational databases in our colleges. The traditional applications that have fixed column, fixed data type, fixed schema, they're called relational databases. And they're used in traditional applications, ERP systems, CRM systems, e-commerce, and so on and so forth. So these are some of the engines that AWS has, right? Amazon Aurora, which is MySQL and Postgres SQL compatible. Postgres, again, is a very popular engine, right? It's a relational database engine. It's open source, and it's free, and it's a very popular database engine, which is used of late by a lot of enterprises, a lot of applications. RDS, yeah, RDS is again, it's again a relational database service which uses Oracle, MySQL, MS SQL, MariaDB, Postgres SQL, right? So these are the engines that are supported. All the famous engines are supported in RDS, right? So you can just provision an RDS with one of these engines and you would get that as a fully managed service. Redshift is a data warehouse, right? So again, data warehouses, enterprises generate a lot of data and they would want to process it at scale, right? So Redshift is, it's a very widely used cloud data warehouse. Key value, right? What is key value databases? They are, as I said, they don't have a fixed schema. Everything is stored as a key value pair, right? And you can query a key and it will return all the values associated with that, right? It's used for high traffic web applications, e-commerce systems, gaming applications. DynamoDB is one such database, which is Amazon's own engine, right? Amazon built this DynamoDB, which is a flexible NoSQL database for any scale, right? And again, it does not have any constraints like relational database, right? For example, like relational databases like say SQL Server or Oracle has got a limit in the data that it can store, but NoSQL is not like that. It can store any amount of data and process any amount of data. So that's the distributed database, that engine that it uses, right? It stores the data in multiple different distributed systems, and that's how it's able to maintain copies and achieve that scale. In memory, you can use it for caching, you can use it for session management, and so on and so forth. Elastic Cache and MemoryDB for Redis. These are two data stores that we have in AWS. DocumentDB, Amazon DocumentDB with MongoDB compatibility. So this is where you actually can store some documents, correct? Using JSON, and you could store JSON very easily, build documents out of it. Wide column key spaces is one database that Amazon has for a wide column. It's used for high scale industrial apps for equipment maintenance, fleet management, route optimization. You want to choose the shortest route, so then you should probably go for key spaces. Again, Neptune is a graph database where it actually builds relationships, and it can query millions of relationships between highly connected graph data sets. Like you take LinkedIn or Facebook, right? So this kind of databases, or this kind of use cases would actually require a graph database, correct? Like social networking, right? If I'm connected to say 1,000 people or 100 people, how are those 100 people connected to the rest? Right? So that kind of use cases, you would need a graph database. You can also achieve that in a traditional relational engine, right? So, but again, you will not get that scale and you will not get that flexibility that you get on these kind of databases. Time series, as I said, it's used for industrial telemetry where you want to get, minute by minute, status about metrics about certain equipments, and you store it in time series, and on top of time series, you'll be able to directly run some algorithms and understand, how the anomalies are being detected. Ledger, again, it's a blockchain-based database. It's called QLDB, Amazon Ledger Database Services, are used for supply chain, systems of record, registrations, banking transactions, and so on and so forth, right? So where if you want to achieve an immutable transaction, which cannot be tampered and tamper-proof, you actually go for ledger databases. Okay, so these are some of the types of databases that we have. We'll quickly watch this video as well to see what it is.
Feeling stuck to your old guard database provider with big price tags, high lock-in, and punitive licensing terms? Break free with AWS databases, which give you the scalability, performance, and availability of commercial-grade databases at 1/10 the cost. Hundreds of thousands of customers have saved time and cost, improved performance and scale, and innovated faster by leaving legacy databases behind and moving to AWS purpose-built databases like Amazon Aurora, Amazon DynamoDB, and Amazon Redshift. AWS databases are fully managed, freeing your teams from the time-consuming and undifferentiated heavy lifting of database administration, so they have more time to build applications. AWS databases were designed from the ground up with serverless auto-scaling and self-healing designs to help you scale quickly without worrying about performance and availability or being paged in the middle of the night for maintenance. AWS databases offer 3 to 5 times the performance of popular alternatives, while scaling to support millions of requests per second with single-digit millisecond latency and storing petabytes of data. AWS provides the broadest selection of commercial-grade, purpose-built databases, allowing development teams to build and innovate faster on any application use case. AWS offers more database engines than any other cloud provider, including relational, key value, document, in-memory, graph, time series, and ledger databases. Hundreds of thousands of customers have started saving time and cost, improving performance and scale, and innovating faster by moving to AWS databases. Join them. Gain database freedom at aws.amazon.com/databases.
Yeah, so these are some of the features of the AWS databases. So let's quickly look at. So these are the engines, right? Aurora again is a engine that AWS built, Amazon built, and it's compatible with MySQL and PostgreSQL. And Aurora has got even a serverless database where you don't have to worry about the underlying size. You just keep using it to the extent that you want. You'll only be charged for what you use, right? Unlike RDS, where you have to provision, you have to define, what is the size of the database that you want upfront, right? And you can only use that within that, and irrespective of whether you use or not, you'll be charged, correct? It's like an EC2 instance. But Aurora is not like that. Aurora is like a platform as a service, complete. It provides you a serverless capabilities where you don't have to manage any server. You just make use of it, and you're only charged like per transaction or based on the amount of CPU that you consume. In Redshift, DynamoDB. So these are some of the databases that AWS offers, and also AWS offers something called database migration service. If you want to migrate from your on-premise database to AWS, one of the engines, you can use this database DMS to migrate. It can be within the same engine, or it could be across the engines as well, right? For example, you have SQL Server and you want to migrate to Aurora, right? You can use DMS to migrate from SQL Server to Aurora or an RDS. Excuse me. So database freedom is one theme that AWS, takes very aggressively to customers in terms of to break free from the traditional licensing models that the database engines offer, right? And to move away from that, so you can read more about it out here as to what is the value proposition of database, AWS databases across, performance, cost, and so on and so forth. And here you can actually learn about, for those of you, who are new to databases, right? I mean, who have never learned databases as part of your academic careers, you can actually start from here, right? What are databases? And you can actually start from here, and you can try and understand the fundamentals of databases out here. And okay, let's look at RDS, right? So first, let's look at RDS. Okay, so RDS is called Amazon Relational Database Service, right? As the name says, it offers relational database services. Okay, which means the traditional relational database services is what it offers, right? So now, the engines that RDS supports are Aurora. Aurora, it's, as I said, it's Amazon's own database engine. PostgreSQL, which is an open source. MySQL is an open source. MariaDB is also an open source. Oracle, it's not an open source, it belongs to Oracle. SQL Server is also not an open source, it belongs to Microsoft. Okay, so these are the engines that RDS supports, right? You can, when you provision, say you want to provision a Microsoft SQL Server, you choose the Microsoft SQL Server flavor of RDS and provision it. If you want Oracle, you can just go choose an Oracle version and provision that. Similarly, if you want the MySQL, you just choose MySQL and provision it. Right? So these are the 6 engines that AWS Amazon RDS supports. And what is the advantage? Advantage is, as I said, you don't have to manage the underlying infrastructure, right? You won't be able to log into that virtual machine, and you don't have to do those traditional housekeeping activities, right? So usually when enterprises build applications, there is a separate team called the database team, and there will be a bunch of database administrators whose job is to maintain the underlying infrastructure of those databases and keep them healthy all the time, right? That's their job. But here in this case, the database administrators need not worry about the underlying infrastructure. That whole thing is taken care of by AWS. They only need to worry about the health of the database, right? How much optimized are their indexes are, right? How well the database is performing, how well the queries are performing, things like that, right? They just need to only worry about the database aspects. Has somebody worked with databases? Can someone tell me what are indexes in a relational database? What is an index? You learned it in the beginning of this course, correct? You learned PL/SQL, of course. It's an interview question.
DDL?
No. What are indexes?
It is a database structure which is mainly used to improve the performance of an activity, and just like a serial, by providing serial number.
Okay, no, that is primary key. What you're saying is primary key. But okay, in a way, you're partially right. But what is the definition of an index? See, it's like your index in the book, right? I mean, when you buy a book, towards the end of it, you'll have an index, correct? It will tell you for a specific chapter or for specific keywords, you refer to so-and-so page. Okay, it will be organized in such a way that it will have some sort of an alphabetical order, and you just follow the alphabetical order, go for the keywords that you want to refer to, or it will immediately tell you where it is stored, correct? Or where you can find that particular keyword or that particular chapter, correct? So indexing is
database.
Yeah, so the indexing is nothing but, it's a way to optimize the way the data is stored database maintains some sort of an index so that it can be quickly, the index will be looked up and the data will be retrieved. So it's a, instead of scanning the entire table, assume a table has got say 10 million rows in it, correct? So now if you're wanting to fetch the 5th million row, then it need not traverse through all the 5 million rows to fetch that 5th million row, correct? And that's called the scanning. That's called database scanning. You don't have to scan the entire database, right? So instead you can simply refer to the index and figure out where that 5th million row is there, go to that particular sector, read it, and take it back. So anyways, read more about some of these indexes. And these are all interview questions. Okay, indexes, primary keys, foreign keys, joins, right? So you learned a lot of these, right? I mean, you would have learned about these in your college and even at the beginning of this course uh, through DDL and DML. But it's also important you learn some of the database administration activities to improve the performance. One such is reindexing. You have to always reindex the database administrators reindex the table so that it rearranges it and performance will be much better. Okay, coming back, so these are some of the engines that RDS offers and which are easy to administer, highly scalable, and so on and so forth. Anyways, let's jump into lab and see how we create a database, right? So here I'm on the AWS console. I'll search for RDS. I'll go to RDS. Yeah, so let me just move to Mumbai region. Okay. And RDS offers a free tier. Okay, if you just read this free tier, right, it does offer a free tier. As part of the AWS free tier, RDS helps new AWS customers get started for free. 750 hours of RDS single AZ db.t2.micro instance usage running MySQL, MariaDB, Postgres, Oracle, or SQL Server, running SQL Server Express Edition. Okay, if it is Oracle, bring your own license, then it offers. Otherwise, it does not offer. Otherwise, it will be charged. So it's better to go with one of these three open source engines, right? Either MySQL, MariaDB, or Postgres, because Oracle and SQL Server are not open source. They are like proprietary databases, which are owned by both Oracle and Microsoft. So don't go for it. Go for MySQL, MariaDB, or Postgres SQL. It offers 20 GB of general purpose SSD. If you provision IO1 or IO2, you will be charged. Okay, what is IO1, IO2? They are provisioned IOPS SSD. Okay, and then it also gives you 20 GB of automated databases, automated snapshot. Okay, all right, let's go back. So here it tells me, it gives me a dashboard of what all databases that I have. Correct? Okay, so now what we are going to do is, in fact, I'm going to point you to something which will allow you to, these are some hands-on labs that AWS offers just to bootstrap. This is one such lab where you can create and connect to a Postgres database with Amazon RDS. Cost to complete is free tier. If you have free tier, you can just complete it within this free tier. Okay, and services used is RDS. So in this tutorial, you will learn how to create an environment to run your Postgres SQL database. We call this environment an instance. Connect to the database, delete the DB instance. We will do this using Amazon's relational database service, RDS. And everything done in this tutorial is free tier eligible. Okay, so let's just get into the first one. Enter the RDS console. Yeah, we are in the RDS console. Okay, and then the next step is to create a Postgres SQL and choose the region that you want to choose, right? Then what you do is go click on create the database. This one, we're going to do that. Let's click on create the database. Okay, so here, go for the standard create. Okay, just go for the standard create so that you will learn the configurations that are there. And here you can choose the PostgreSQL as the engine, okay, which is a free, right? Again, if you go for SQL Server, then it will be charged, right? So go for PostgreSQL, and the engine that you want to use, just choose the version, the correct version. I mean, just go for the either latest or latest -1, n or n-1. Just go for 13.3-R1. Okay, so here there are some templates that are available, right? You can use a production grade instance, or you can just use a dev test. Dev is development, test is testing. So you can use a development or testing grade instance, correct? So now if you go for a production instance, then what will happen is you don't basically, by default, it actually chooses m6g.large, which provides 2 vCPUs, 8 GB RAM. And it also provides you by default a provisioned IOPS SSD, right, of 100 GB with 3000 IOPS. So now there is cost associated with this option. If you go ahead and if you ignore this step, and if you simply go ahead and choose a production and continue with this and create the database, you can expect a huge bill on your account. So please remember that. Please don't do that. Okay, just pay close attention to what I'm trying to tell you right now. In the templates, don't choose production, instead choose the dev test. Okay, so when you choose the dev test, what you get is you still get this, but here you'll be able to choose the burstable classes. Choose the burstable classes and say t2.micro. You have to turn this on, include previous generation classes, turn this on, and you can choose t2.micro. Okay, let me just check why is it not coming. Okay, these are all M series. This will only include R and X. So T is where I need. T3, T3. Okay, probably the T2.micro is deprecated. Okay, let me just try this easy create. Okay, R6G. No, don't go for this easy create. Go for the standard create. Dev test. Okay, it's strange. I'm not sure why is it not showing me T2.micro, or I think the free tier is, I don't have the free tier, I believe. Okay, let me just stop screen share. I'll open another account and come back. Yes. Okay, got it. So, okay, it's like this. Basically, Postgres does not offer a T2.micro. Okay, so if I choose a different engine, for example, in this case, I chose MySQL, right, instead of Postgres. So MySQL actually offers a free tier, right? So Postgres doesn't offer a free tier. Okay, so if you actually go here and choose, you either get a production or a dev test, right? So now, which means that you don't have a free tier, right? So instead, choose MySQL, which is fine. So instead of Postgres, you just go with MySQL. That's okay, right? So here, actually, what you can do is, let me see if there is a hands-on for MySQL RDS. Yeah, so this is the one that we need to follow. Okay, so instead of Postgres, let's go with a MySQL. And since you get a db.t2.micro, which is eligible for a free tier, in MySQL it is possible, right? So if you go click on create database, just click on standard create, click on MySQL, and you have to select free tier. Right? So that's what we have done. Standard create MySQL, go for MySQL Community Edition. Just leave it default, and then here you choose free tier, which is the T2.micro. And then what you do is, the next step is to give a database instance identifier, and master username, master password, and confirm your password, right? You can just give these of your choice. Right? In this case, RDS MySQL 10-minute tutorial, right? I'll just change this to my RPL RDS lab is the name of the database that I'm going to give. And master username, they've just given some master username. I will just leave it as admin, and I'll give the password as just password, plain password, PASSWRD, right? So that's the name that I've given. Then out here, the moment you choose free tier, it's going to choose db.t2.micro, right? So just leave it like that, don't change it. And then the storage type, it is going to leave it as default as GP2. Don't change this. The moment you change this to IO1, beware, you're going to be charged in your account. In fact, last year, a lot of students did this mistake of forgetting to choose this free tier, right? So they just went for production. And there was a huge bill in their respective accounts. Okay, so I don't want you to do that same mistake. So instead, pay attention to this template, choose the free tier, right? And ensure that you're only choosing the general purpose SSD with 20 GB. Don't change this as well. And what you can do is you can disable this, right? Enable auto scaling, storage auto scaling. You can just simply disable this. You don't need this because you're not going to, pump more data so that you need more storage. All that we're just simply going to do is to provision this database, create some tables, and run some queries, right? So that's all we're going to do. Then multi-AZ will not become available in free tier, so just leave it as it is. But when you build it for production, you can actually choose a multi-AZ deployment where it actually stores the primary node in one availability zone, and it will also create a second node of the same engine in the other availability zone, so that if one AZ would go down, it will basically promote the secondary as the primary. It's basically an active passive, and all the data that goes to the primary is synced with the secondary node in real time, in near real time. Okay, so that's the advantage of using a multi-AZ deployment. It will give you better availability, high availability. Okay, and then for the VPC, just choose your VPC that you just created some time back, right? And subnet group, it would have created a subnet group. Just leave it like that, and it will ask you whether you want a public access or not. Correct? Yeah, say choose yes, public access, right? Because you want to access it from your laptops or desktops. Correct? Yeah, so you have disabled this, right? Have disabled this. Just you have to simply follow this article. Okay. connectivity and make the publicly accessible as yes. And then VPC security group, just go ahead and create a new security group, because at the end of the day, you need to, like EC2 instances, even RDS, you have to allow the traffic to flow in, correct? So that's where you need a security group to be created. Okay, you create a new security group and give the name to that security group, right? Create it as RDS SG RPL lab. That's the name that I'm giving. Availability zone, you can choose an availability zone. I'll just go for 1A. And then some of the additional configurations of the port on which this MySQL runs is 3306, right? Again, all of us are aware of what a port means. These are standard ports that are used by these databases, right? So it's 3306. And authentication, you can just simply leave it as password authentication. Okay. And then it will also tell you what is the estimated monthly cost. Okay. And backup, you can enable automatic backups, right? Just to check, how the backup works. You can go to additional configuration. The initial database name, you can just give an initial database name as employee, right? Employee is the database name that I want to give, right? So that's the standard one that I'm giving. So I'm just giving it as employee. So what it'll do is it'll create the engine, and it'll also create a database called employee, and leave the remaining as it is. Keep it enable automated backups as checked, and a backup retention period, you can just make it probably 1 day, right? Just change it to 1 day. So then don't change any of the other things, right? So just leave everything. So if you enable enhanced monitoring, then you will be charged additionally. So don't enable the enhanced monitoring. So then you have maintenance and so on and so forth. Leave all of that. So here it will tell you RDS free tier is available for 12 months, right? So this comes under free tier. So then what you can do is you can simply go ahead and create the database. Hit on create database. So it's going to provision the database, and it's going to be ready in a few minutes. Okay, so if you see, it's actually creating it right now in my VPC. I mean, you won't be able to see it under EC2 instances. Okay, even though it's created, you won't be able to see the underlying EC2 instance or all of it, because it's a completely managed service, right? You don't have to worry about it. You are creating a database engine which you can connect to and access it using a client. You won't be able to log into that operating system where this database is running, right? So that's the multi-tenant model that AWS manages internally. Okay, so yeah, it could take several minutes for the new database instance to become available. Okay, so now what we can do is, while the database is getting created, we need some sort of a client, right? We need some sort of a client to connect to our database, the newly created database. So that is where you can use MySQL Workbench. Okay, so now if you just go here and download MySQL Workbench, it will take you to a new page. Depending on your operating system, it will automatically choose, and I'm just going to download this. No thanks, just start my download. Save file. So I'm just downloading that MySQL Workbench. It's nothing but a client, right? I mean, when in Oracle you had used something like Toad or some PL SQL client, right? Here also you need something like that. So to connect to your database. So just click that. I'm just installing it on my laptop. Just update applications. Oh, I already have it. Okay, let me just replace it. Yeah, so it's done already. Let's just go and let me open MySQL Workbench. Yeah, MySQL Workbench is there. Let me just pull it up, open it, just open it. If I go back, yeah, so if I go back, next step is to basically connect to the MySQL database. So you can just go open the MySQL Workbench. So here you can just go to databases and connect to a database. So you have to give the host name. So where do we get the host name from? If you just go back to the RDS console, yeah, if you refresh this, it's actually created, but it's doing a first time backup. But I think it's created, right? So once it comes to the status as backing up, which means that the database is active. Okay, it's available, it's online. You can try that. So this is the endpoint that you have to use. This is the public endpoint that you have to use. So copy this public endpoint, come to the MySQL Workbench and leave the rest of it as default. Then the username should be the username that you created, correct? Earlier that you created. So what is the username we gave? Admin, I think so. Admin is the username that we gave. Go to the configuration, you will see what is the username. Yeah, it's admin, right? Master username is admin. You can just give it as admin. And you can give the password as password.
So default password is password, sir.
That's what I gave.
Okay.
But you have to give a default password when you create it. Okay, but that's what I gave. Okay, so just click on this. Okay, yeah, see, it's connected now. It's connected to my database. Okay, it's connected to the database. And if I just click on the schema, you will see all the database schemas that are there. I created something called employee, right? The employee is there, but there are no tables right now. I can just go ahead and create a new table saying EMP underscore details. Okay, and you can just add a new column to say EMP ID integer, which is a primary key. Okay, then first name. Okay, varchar 45. Last name, something department, something whatever, right? I mean, yeah, I think that's fine. So I'll just go ahead and create this and say apply. Yeah, so it'll just generate the script for you to create the table. Just apply it. Yeah, it's done. Yeah, so now if I go back to my schema and refresh all, I will see the tables as employee details. This is the table that I have, right? And then I can run a query saying select star from EMP underscore details. Yeah, so there's nothing. No database selected, correct? So that's, I have to first select the database which I want to use. In MySQL, it is use employee. Yeah, see, it's giving me the table, the contents of the table. Right now, I don't have anything here, so it just gives me. Anyways, I mean, the intent is not to teach you databases, but so that's how you go ahead and use. And what we have done is we have just provisioned a fully managed MySQL RDS instance on the cloud, and we were able to connect to that RDS as well from one of the clients that we have downloaded from the internet, correct? MySQL Workbench. It's an open source free tool that you have. Okay, so now if you go back, you will see the list of databases that you have, right? Just refresh it. Yeah, it is still backing up. That's okay. It's just doing a first one-time backup. And you will see how much of CPU is consumed, how many active connections, correct? And you have, and what is the size, right? So it's t2.micro. Okay, this is the endpoint, which VPC that it is provisioned in. What are the security groups, right? What are the security groups? In this case, I selected a security group. It took my IP address, 49.37.168.121. Is that my IP address? What is my IP? Yeah, 49.37.168.121. Yeah, that's the IP address it took, which is allowing only my IP address to connect to the database. That's why I was able to connect to it. In case if you are having issues, you have to go to the security group. And this is the standard security group, right? So which you see in the EC2 console. Inbound rules is this. You have to go and modify this security group in case if you have issues. Okay, and I'll be able to look at the monitoring, how many database connections, how much is the CPU utilization percentage, free storage space, free memory, IOPS, read IOPS, write IOPS. So some of the metrics that you can, it's created now, successfully created. If you see, status is available. Okay, and if you see, it will also take a snapshot or backup of this database, correct? So if you go to the database, if you go to the automated backups, since we selected for automated backup, it will automatically take the backup of this entire database. In case if something happens to my database, if I have to restore it from a backup, I can restore it from a backup. I can just go here, create a database. I can restore it from the backup. Okay, so that's how simple. So now let's go ahead and do a cleanup. Now just go ahead and delete the database instance. Just select the database instance and click on delete actions, delete. Yeah, so it's going to ask you want to create a final snapshot or not. I don't want to create any final snapshot because it's going to add to my cost. Okay, so now it'll ask me to input this text, delete me into
Sir,
this field.
one doubt, sir. Sorry to interrupt.
Yeah.
Sir, we have connected from one system only, right, sir? Then why it is showing two connections, sir?
Okay, so see, one connection is, since it's a managed service, correct? Where when what AWS does is, AWS runs some scripts behind the scenes, which will not be visible to you and I. So those scripts, what they do is they connect to the database. I mean, of course, it won't have access to the schema and all. Right? It won't have access to your data. Your data belongs to you, right? AWS does not peep into your data, okay? Because AWS will not have access to it. But AWS will have access to that box or the instance where the database is running, correct? So it will also deploy some scripts which will be used to back up the database, okay, at the intervals that you specify. So those are the maintenance activities that AWS does as a managed service. So now the other connection that you saw is basically a script that was running to do the first time backup of the database. That's the reason you have the second connection as, you see two connections there.
Okay. Thank you, sir.
Sure, but good observation. Thanks for that. Okay, I'm just going to go ahead and delete it. Click on delete me. Just click on I acknowledge and then type delete me and then just go ahead and delete. It's just going to go ahead and simply, delete this. And after that, you can also go ahead and delete any automated backups that are created by just selecting this. Okay, I think this will go away, I believe. Yeah, it's gone, right? So the database is also deleted. Yeah, so it's still deleting. So this is how you go ahead and use an RDS I'm just going to close this. Let me quit this. I don't need that any longer. Okay, that's one type of database that we just provisioned. The other type of database that we're going to provision is called DynamoDB. Right? So I'll also show you how to create a DynamoDB. So DynamoDB is a managed NoSQL database in AWS. RDS is relational database service, right? So where you have the traditional relational database engines can be created using RDS, whereas if you want a flexible NoSQL database, right? So how many of you are aware of what a NoSQL database is? Have you worked with any NoSQL, or have you read about it? If you go to Amirpet, in Amirpet, you have those institutes, right? You will have a lot of, banners that says NoSQL all over the place. You will find it. NoSQL, right? So which Hadoop, Cassandra, right? So these are some of the NoSQL databases that we have. Have you ever observed it? NoSQL databases, training course on NoSQL, 15 days, 20 days, 1 month. Yeah. Okay. Anyways, I'm going to give you this link and you can actually go through this. Okay. So now let's also go and do a DynamoDB. Yeah. So let's just go ahead and do a DynamoDB hands-on. Yeah, create and manage a non-relational database. So this is what I was looking at with DynamoDB. Okay, so this is a full-fledged, right? So I don't want to use this. We'll come back to this later, but I have a shorter version of this thing out here. Yeah, I'm going to give you these two links, right? So don't worry, I'm going to give you this MySQL. MySQL database. Right. Okay, so let me just go here. So this tutorial, you will learn how to create a simple table, add data, scan and query the data, delete the table using the DynamoDB console. So DynamoDB is a fully managed NoSQL database that supports both document and key value store models. At the end of the day, it's a key value pair, right? It's flexible data model, reliable performance, and automatic scaling of throughput capacity make it a great fit for mobile apps, web apps, gaming applications, advertisement, IoT, and many other applications, right? Everything done in this tutorial is free tier eligible. And AWS free tier offers 25 GB of storage up to 200 million requests per month with Amazon DynamoDB. Okay, let's first start, right? So first go to DynamoDB. Let me just go here, navigate to DynamoDB, and you will see this page, right? And if you click on tables, you won't have any tables right now, right? Because it's a fresh. So now let's first create a table, right? So the way it works in DynamoDB is, unlike MySQL, in MySQL, what we did was we created a instance of t2.micro, which has some predetermined CPU and memory allocated to it. After that, what we did was we created a database schema called employee. And after that, what we did was within that employee, we created a table called employee details. And within that table, we defined the data model for that table, such as employee ID, first name, last name, department, and so on and so forth, right? And we defined this is the primary key, right? So the type of the data structure on that particular column, right? And then we queried the database, right? So it's a fixed column, right? You won't be able to change the columns, right? I mean, every row in the table will have to follow that column structure. You can't have columns, half of the rows in the table, following the column structure, the rest of the rows in the table not following the column structure. Okay. But whereas in a NoSQL, it's not like that, right? In a NoSQL, you just simply go ahead and create a table. That's it. Table is everything for you. Within the table, you can store any type of data of any rows, can follow any column structure, right? It's not a fixed. I mean, every row need not follow a fixed column structure. For example, row number 1 can have 2 columns. Row number 2 can have 5 columns. Row number 3 can have 10 columns, right? Sorry, just give me a second. Yeah. Okay. So it doesn't work that way in a DynamoDB or a NoSQL database, right? So you create a table, and within the table, you can have different rows with different column structures. Okay. So anyways, let's go ahead and first create a table. I'm just going to go and click on create table, right? I'm here in this case, I'm just going to follow this tutorial, right? So for the sake of simplicity, I'm just going to create the table name as music. Just click on create table, just give the table name as music. Okay. And then yeah, it's just giving a table name as music. Okay. Usually if you take databases, right, and you will have some sort of a primary key, correct? You'd have learned about what a primary key is. Primary key is a unique identifier for that, for each row, right? So even in NoSQL, you have something called the partition key. Partition key is nothing but that's the primary key. How the data will be stored in various different shards behind the scenes, right? If you learn more about how the data is actually stored in NoSQL, there are so many articles for it. You can just read about it, right? As to how the database data is actually stored in a distributed fashion across multiple different shards in the underlying storage. Okay, so I'm not going to give any primary key or the partition key for now. In fact, if you will see a slight difference between the user interface of this and this, because this uses a new user interface, whereas the tutorial that you're seeing here uses a slightly older user interface. But at the end of the day, it's all one and the same. So don't worry about that. Okay, so then what it does is the next step, the partition key is used to spread data across partitions for scalability. That's what I was saying, right? I mean, it uses this key to spread the data across all the partitions. In this case, the primary key or the partition key that the tutorial is asking us to create is called an artist, right? So let's also create that artist here. Artist, and it's a string. Okay, you can choose what you want it to be. You want it to be a binary or number or a string. Okay, it's a string. And then Okay. Because each artist may write many songs, you can enable easy sorting with a sort key. Add the sort key checkbox, type song title in the add sort key box. Okay, see what we're trying to do is, okay, we're actually trying to create a music app. Okay, a mobile app or whatever, right? A music app. So where we want to store the underlying data, music data in this table, which has got artists, which is partitioned by multiple different artists. There could be thousands of artists, right? So we'll be actually storing the music library from thousands of these artists. And for each artist, we want to actually have some sort of a sort key so that it is arranged by the titles of the song. Okay, like you take A.R. Rahman, Ilayaraja, right? So you'll actually have all the songs from A.R. Rahman, all the songs from Ilayaraja arranged in the alphabetical order, right? So by the title. Okay, so that's what it means. Okay, so that's the sort key. Sort key is nothing but, you can easily sort the data within the DynamoDB table using the sort key, so that your retrieval also becomes a lot more efficient. That's the whole idea of a sort key. Okay, so then next, you will enable DynamoDB auto scaling for your table, right? So if you see here, DynamoDB auto scaling will change the read and write capacity of a table based on request volume, right? And you're actually going to, what you're going to do is you will start small, right? As usual, because you're creating a music app, right? You don't know how well the music app is going to do, right, on the market. But if your music app does well, you want the underlying database also to scale according to your, according to the business volume of your music app, right? So from that perspective, what you do is you actually go ahead and enable auto scaling on your underlying DynamoDB table, so that your DynamoDB table will automatically scale on your behalf. Okay. DynamoDB creates this role for you the first time. You enable an auto scaling in this account, right? Instruct DynamoDB to create the role by clearing the use default settings. Okay. Here you have to go with customize settings and just go for DynamoDB standard. Okay, go for on demand. Okay, do one thing. Ignore this for now. Okay, we'll come back to this. I don't want you to, deal with a lot of settings at this in the first lab itself. So here, just go for the default settings for now. Right. So when you create, just simply go ahead, create the table name as music, artist as the partition key, song title as the sort key, and settings, just leave it default for now. Okay, don't change anything. Just go for a default settings. Just leave everything as it is. I'm just going to give you this as a screenshot. Okay, just leave it like this. And if you want, you can create a new tag. Just give the name tag music table. So that's the tag that I'm giving. And then just go ahead and create the table. Yeah, so if you see, the DynamoDB table is getting created for you. Okay. Yeah, the table is created now. Okay. So now let's see what the next step is. So just go ahead and create the table. Forget about all these, right? The roles and everything, just ignore it for now. Just leave everything as it is. Add data to the NoSQL table. So now what you can do is you can just go open the table. So just click on this table. It will open the table. So here on the top right side, you will see view items. So just click on this view items. And then you will see that there are no items in this, right? So right now it's empty. The table is fresh. It's empty. So now what you can do is you can just create item. The interface will be slightly different. You will see create item as a blue button here, but whereas the create item is a white button out here. Just click on create item, and you will see, these are the attributes and these are the values, right? So that's why it's called a key value pair. Okay, it's a key value pair database at the end of the day, right? Because each column and column value is basically represented as key value pairs. Okay, so now what you can do is you can actually give an artist and song title, right? Okay, you can just use the same. No one you know is the artist, and call me today is the song title. Yeah, so just click on create item. So it's going to insert that item here, right? So if you see, artist is this, song title is this. Okay, then click on the save item. You're good, and you can add more items. You can insert more items with no one you know as the song, as the artist. My dog spot is the title. Song title. Just create this. So the reason why the demo is showing this is it's actually using this primary key, right? So that all of these are grouped together, and the sort key is by the actual song title. Somewhere down the road. Then the Acme band, still in love. Yeah, so we're just simply inserting rows into our table. Okay, that's what we are doing through this. So this gives you this user interface, nice user interface to fetch it, right? So if you go back, you can always come back to that by clicking the tables, click on music, click on view items, or you can also go from here, right? So click on these items and select the table, which table, select this music, and just click on scan, use the scan, or you can also query it, right? You can use a traditional SQL interface and query this as well, right? Okay, all right. So now these are the items that you have, right? So now you can go ahead and query the NoSQL table. In this step, you'll search for the data in the table using query operations. In DynamoDB, query operations are efficient and use keys to find data. Scan operations traverse the entire table. Okay, in the drop-down list in the dark gray banner above the items, change scan to query, right? So if you go here, you can just change this to query. You can use the console to query music table in various ways. For your first query, do the following. In the artist box, type no one you know and click on start search, right? So here you can just, this is your primary key, correct? You can just select no one you know, and then just click on start the search. Just click on run. Okay, so when you click on run, you will get all the rows which has no one you know. Okay, and then you can in the another query just type Acme band, and all the this thing for Acme band will be responded with, right? And also you can give the title as begins with, right? Acme band and begin with, or I can just do my dog spot, right? I want to basically query for a certain song title. You can just go ahead and use the sort key as song title equal to my dog spot. Just click on this, you will get my dog spot. Okay, so that's how you go ahead and query this. And now what DynamoDB does is it gives you APIs, right? So from applications, you may wonder how you do and how you go ahead and use this in applications. In applications, you can actually go and use APIs, and you can basically pass the query to the API, and fetch the cell set like how you typically do it in a DAO, and then you can use that to use the data. Okay, and if you want to delete an existing item, you can just simply go. You can go to the tables. You can go to click on music. You can click on new items, right? Okay, let me just go ahead and do a scan. Scan will just filter everything. I can just select one of them. Actions, I can just go ahead and delete items. It'll ask whether I want to delete it. Yes, go ahead and delete it. Okay, and also what I can do is I can just go ahead and add more attributes, right? Like that's the difference between a traditional tables, which you do in relational database versus a NoSQL database. In RDBMS, when you have defined the table structure using a data definition language, you won't be able to change it until you rerun the data definition language and again restructure the database, right? So you want to add a new column, then you have to again add a new column, and then that column will be applied to all the rows in the table, correct? That's not the case in MySQL. In MySQL, you can randomly add, right? So for example, in this case, I want an artist. Use the same here. No one you know. Create an item. It's a new song title. I just give something. I can add a new attribute here. I can say another string. I can say, I can give the thing and say that this is a new genre. Okay, and then I can just say create item. So it's just going to go ahead and create that item. That's the beauty of it. If you see this, it's just going to create and it's going to leave the rest of it as blank, right? Now, if what you can do is you can just simply go query and say, just remove this, and say run. Yeah, you'll get this, right? And what you can also do is you can add more filters with attributes, right? You can say that this is a new, or I can say equal to or contains, right? I can just say contains new. I want to basically look for all the genres that contains new, right? Just go and click on run, you'll get this. Right now, I can also go ahead and create a new this thing saying for the same, no one you know. I will just go create a new item, and I will say that this is another item. This is another song, and then I can add a new attribute that says this time it is what are the other things that usually you get in the music app? One sec, let me just open my music app to see if it yeah, album, right? I mean, which album this belongs to, right? This is a new album. Okay, let's go ahead and create that. You see, I mean, so all these, see, look at this. There are there are two which has, let me just remove this, right? So let me just remove this filter. Okay, and then let me just run this for no one you know. If you see here, some rows have got only song title, right? All the rows have got a song title, but some rows have got album as an additional attribute. Some rows have got genre as a additional attribute, right? So this is how each row in a NoSQL can be of different definition. So it's like this, right? You have DDL for each row, unique DDL for each row, right? You don't have a fixed DDL for every row, unlike a standard traditional database, standard traditional RDBMS. Okay, so that's how the whole DynamoDB works, right? So because it's a NoSQL database, and now what you can do is you can just go ahead and delete the NoSQL table and just simply click on this and say delete. Yeah, delete all CloudWatch. No, you don't need a backup of this. I'll just simply say delete and say delete.
Sir, sorry.
That's it, it's deleted.
One more question.
Yeah.
Sir, if we created another row with the same column name, genre attribute, if it will be in the same column, sir.
if you create another row with a different attribute or the same attribute.
Same attribute name called gener, sir.
It will be in the
Then
same row. So it will be in the same column, basically.
Okay, sir.
It will be in the same column. So see, that's where, right? I mean, you don't have the notion of columns at all in the NoSQL database. I mean, while it may look like it is in the same column, that's how you look at it. But actually, the way it is stored is it is simply stored as a key value pair. That's it. So now when you just go ahead and query for, all the rows that have got a gender as certain gender, so then it will simply go ahead and fetch all those attributes. It will return you the results. So there is no notion of a column as such in NoSQL databases.
Okay, sir. Thank you.
Okay, so you can read more about NoSQL database. It's quite interesting. Okay, and it's very different than the traditional SQL databases, right? So the traditional relational databases. Okay, all right. So I'm just going to give you this lab exercise for today. Okay, so learn these two, very important, because the projects that we're going to do, the next couple of projects that we're going to do are going to be purely based on these two databases. One is going to be on MySQL, the other one is going to be on DynamoDB. Okay, so I'm just going to give you this in the chat. Let me paste it in the chat. Yes, I've given you the assignment for today. So please get into your breakout rooms and you can do this within your free tier accounts, right? So don't, as I said, remember those things very clearly. Choose only the free tier for MySQL RDS. Don't choose production or dev test. So then, and don't change the storage EBS volume or the storage SSD. Don't change it from general purpose SSD to IO1, IO2. Okay, and in DynamoDB, just follow the instructions that I've given the screenshot. Use the default settings and just go ahead and create the table, and then you should be done for this lab session. Okay, all right. So then I will see you all tomorrow, right? And have a great day. So please complete the lab for today, and get well versed with these two topics, so that the projects that we're going to do are purely going to be based on these two topics. Okay, so that halfway through you can actually clear the project. Okay, so thank you so much and have a great day. Thanks, Sai Krishna, Sairam. Thank you, mentors. Have a great day.
Thank you.
Thank you, sir.